Okay, so in the last video, I went over part A of question number 27, where we had 2 runs of heads and 1 run of tails. And there's several different questions about it. And I just want to give, I think I want to go through number D, or example D, which is 5 runs, because I think that's going to tie in the most concepts that we need to know. So we still have, let's just recall that we still have 5 heads, and then we have 7 tails. Okay, so now when we have 5 runs, that doesn't explicitly say how many of heads and how many of tails. So it could either be 3 runs of heads or 2 runs of tails, or 2 runs of heads and 3 runs of tails. So, and let me just explain why in a second. So we could have 3 runs of heads, or it could be something like this. Or it could be something like this. Now, I think we can see the reason for that because there always has to be a run of heads in between every run of tails. So we can't have like 4 runs of tails and 1 run of heads, because there would be nothing dividing the runs of tails. So we really just need to solve for these 2, right? And they are going to be a little bit different, so we have to solve each one individually. So let's just look at this one first. Okay, so we're gonna use this formula that we learned in the last video, and if you didn't understand it, watch the video again. So let's just try to figure out what everything is. So what we're gonna do is we're gonna hold the tails fixed, right? We're not gonna worry about what the order of the tails is yet, although it is gonna matter. Just as an example, I'll just draw a quick example so you can see why it's going to matter. But so we could have something like this: heads, heads, and then we could have tails, 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 and we could have heads, and then we could have tails, 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 and then we could have heads again, right? So we could have this, or we could have heads, heads, tails, and then another heads, whoops, and then another heads, and then another tails, 1, 2, 3, 4, 5, 6, and then 2 more heads. So if we were just holding the tails fixed, as treating them as just one thing each, then these 2 would be the same thing, right? Obviously they're not exactly the same. Even though the order of the heads is the same, the tails is different. So we're going to have to do this in 2 steps. So first, we're just going to hold the tails fixed, okay? So first we hold tails fixed. Okay. So we're going to have our m, which is the number of objects. In this case, it's going to be 5 for heads. So we're going to say n is the number of containers. So we're going to have 3 containers, right? 1, 2, 3. So that's going to be 3, right? And then r is required in each container. Well, we know that we need to have at least 1 in each container. So r is going to equal to 1, right? So then we just use our formula. So we're going to have 5 plus 3 minus 1, and then minus 1 times 3. And then we have to divide that, or we have to put in our m, which is going to be 5, and minus 1 times 3. And that's going to give us, so we got 5 plus 3, that's 8, minus 1 is 7, minus 1 is 6, or sorry, minus 1 times 3 is going to be, sorry, I want to do that again. We got 8, minus 1 is 7, minus 3 is 4, right? And then we're going to have, wait, did I do that wrong again? I'm sorry, I got to do this more. So we got 8 minus 1 is 7, minus 3 is 4. Okay, yeah. And then we have 5 minus 3 times 1, which is going to be 5 minus 3, which is 2. So we're going to have 4 choose 2, right? So that's the way, that's going to be the number holding the heads fixed. Sorry, holding the tails fixed. Now what we need to do is we need to think about, so for each arrangement of heads, for everything about, like, say this is going to be just 1. For each one of these, we're going to have a certain ways that all the tails can be arranged, right? So it's going to, if you think about it, really we have to focus on the way that the tails are grouped. So there's really going to be like 2 groups of tails, right? So there's one on one side and then one on the other side. And then the objects are going to be the tails. So it's gonna almost be like this problem, just as an example. So we could hold the heads fixed now, and we're gonna be having to solve something like this. And that's just kind of like I'm just kind of taking this part and I'll just bring it down there. So this is the part where things can get changed. So it's the same thing though. We can't have something like this. We can't have tails, 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 heads, because that is going to only be one string of tails, right? So that's not gonna give us the right number of strings, right? So we can't have this, right? So now we just have to solve this problem. So in our case, we're gonna have this one. We're gonna have m is gonna equal to 7, right? Because it's 7 objects, which are 7 tails. And then n is the number of containers, right? And that's going to be 2 containers, right? 1, 2. And r is going to be the number required in each container, so we know that we need to have at least 1, right? So then we can just plug in our formula. So we're going to have 7 plus 2 minus 1. And then we're going to have minus 1 times 3 times 2, sorry. And at the bottom we're going to have 7 minus 1 times 2. Okay. So that's going to give us, so let's see. I think an easy way we could solve this. I know it's just addition, but sometimes I get confused anyway because I'm doing the 1 times 2, which confuses me. But we know we got 2 here and we got 2 there, so we can cancel that out. So we're really just going to have 7 minus 1, so that's going to be 6. So we have 6, and then 7 minus 2, so that's going to be 5, right? So for each way that the heads can be arranged, they're going to have this many ways that the tails can be arranged, right? And so we already know that the heads can be arranged this way, right? So the total arrangements is going to be the product of the 2, right? So it's going to be 4 choose 2 times 6 choose 5. Okay, and I guess we could just do the math for this, but so that's going to be 4 choose 2. It's going to be, let's see, 4 factorial over 2 factorial times 2 factorial. So we know that 4 factorial is 24, 2 factorial is 2, so 2 times 2 is 4, 24 divided by 4 is going to equal to 6. And then, so 6 choose 5 is just going to be, so this is just going to be 6 factorial over 5 factorial times 1 factorial. So we know that this 6 factorial is the same thing as 6 times 5 factorial, so that's like this. 1 factorial is just 1, so we can cancel these out. And so that's going to equal 6 also. So the total is going to be 6 times 6, right? Equals to 36. So I'm just going to go back to what we were figuring out in the beginning. So what we just did is we just figured out this one. So we need to add this one and this one together. We need to add this one and this one, right? So, doing this one is the same thing, but it's just you have to switch it around a little bit. So, I think that I'm just going to let you do this and see if you could figure it out. Just remember you have to add both of them together to get the total ways the tosses could result in 5 runs. Alright? So that's it. Thanks for watching.